All right, welcome back, everybody. Our final team for check-in this week, it's Team 5803, Apex Robotics. They're from SeaTac, Washington. Welcome to the show, everybody. Glad you're here. Let's introduce everybody. Let's go start with Evan, then go to Landon, then go to Maura.
Yep.
Hey everybody, I'm Evan. I'm one of the lead mentors for Apex Robotics.
Hello, I'm Landon. I'm one of the student leads on the team.
Hello, I am Maura McDougall, and I am the head programmer.
Cool. Well, welcome to the show, guys. Now, you may also notice that these guys are also in a different layout than they normally are. You guys had a snow day today, too. Is it? That's kind of weird for Seattle, isn't it?
Yeah, it's pretty rare. I think we got more snow than we have in like 5 or 6 years here. There's like, I don't know, 7 or 8 inches at my house and probably about 4 inches at the school, which more than about an inch of snowfall is pretty rare. So we just don't have the infrastructure, the plows and things to clean it up. So schools get canceled, and that means that we can't meet, unfortunately.
Ooh, that kind of stinks. But I know that you guys do a lot of stuff remotely anyway, which is good. So you're not completely out of touch. And you know what? A snow day is always fun, and every once in a while too. So, all right. So let's dive into it right now. Let's talk about your robot design. We saw a lot of great pictures in there from your CAD. It looks like you guys have a full CAD ready. It looks like your robot, your practice robot at least, is pretty far along. Let's get some talk to us about that a little bit.
So this week we got our magic carpet done. We got the gear assembled, and then we also got our collector assembled without the motors and ready to be attached to the robot. And then also on my side for electrical, we also got our electronics panel finished.
Nice, very good. So it looks like a lot of great work is done. Do we want to sort of take a look more closely at the robot parts and sort of see what everything looks like and sort of give an explanation as to why everything's the way that it is?
Yeah, I think that'd be pretty cool.
Cool. Evan, I think you have the ability to show us some pictures of your CAD model.
I can do a screen share. Let me get this ready for a second. So we'll start with just the chassis and the sort of ball intake mechanisms. I'm ready to share.
All right, here it comes.
All right, should be coming up.
Oh, there we go. Excellent. Oh, and it's gone. Uh-oh.
All right.
It's back. All right, whatever
I figured out what the problem was.
Go ahead, Evan.
Okay, so is my mouse showing up too?
Yep.
Excellent. So at the front of the robot, we've got an intake, and it comes out a little bit just to the front edge of the bumpers. We didn't want to do an over bumper intake, and I think Landon can get into a little bit of the details about why later, but it mainly had to do with robot size and not reducing the size anymore. And then in the middle, we've got what we affectionately call the magic carpet. Jennifer Hogue, who was on the show last week, she coined that name. She made sure to let us know that we needed to give her a shout out for that one. But it's basically just a powered floor that kind of slopes back towards the shooter, which is not shown yet. And then we have the gear mechanism on the back, which we call the gearer. And it's pretty simple. It's a lot like what I think Spectrum's shown, and it's just a top roller with a bottom plate and kind of sucks in the gear, and it's very compact in the back of the robot, which is one thing that we really like about that.
So is yours made of carbon fiber, though?
No.
Okay,
ours is made of polycarbonate and aluminum.
Not quite as swag as Spectrum.
Unfortunately. And then the other thing you can see in the front here attached to our intake is the climber, which is not fully fleshed out in the design yet, but it's basically just a 1.25 inch drum that will figure out exactly what rope and how we're capturing it later.
Okay.
Another thing to point out is on the chassis, if you look, we only have 3 wheels. So, as shown in an earlier episode, the inset, and that will come into play hopefully during when we're hitting the field hopper. We can hit it with that inset wheel, where there's not a wheel, to better get a hit and drop the balls into our hopper, which is
Oh, okay. So that was the secret sauce you guys were hiding.
That was the secret sauce. The little cut off corner in the back of the robot is to help us trigger the hopper while the fuel tank of the robot is in position to actually get the balls from the hopper. So it's also just to leave space for us to extend something out there if just hitting it with bumpers doesn't work.
Okay. So let's take a look at some of the other parts, like maybe the shooter or hopper parts.
Let me see if I can get this to switch to another picture here. I have to stop sharing for a second and share again.
Ladies and gentlemen, this is the lovely particular aspect of Skype.
And Microsoft.
And
Microsoft's new photo viewer doesn't like to flip through pictures, so I can't just hit the next button, unfortunately.
So what are we seeing in this picture?
Yeah, go ahead, Landon. Why don't you explain
So
this
in
one?
this picture, you see our shooter as well as what we like to call the funnel. So the magic carpet brings all of the balls into the funnel, and then the funnel will make it to where only one ball is going to the shooter at a time. And then you can't really see it right now, but the two blue wheels that we are using, we're using a smaller one at first for the booster stage, because during prototyping, what we were realizing is that our two big wheels were leaving a gap to where we were just losing the momentum and so forth of the fuel when it was leaving the shooter. So that smaller ball is there so that we can just easily get more torque, etc., to bring it to that ball without having that empty gap in between, because we're able to push them a bit closer.
Okay, very cool. So when you guys are talking about the funnel, whenever I hear funnels and robots and stuff, I assume that's a huge point of potential jamming for the balls. How have you guys mitigated that?
All right, I got it. I got just the picture here.
Oh boy.
Oh boy. Okay.
When it's not the black nothing, it is.
Stop sharing. Share screens. There we go.
All right, here we go. There we go.
So this is what the back of our ball feed mechanism looks like. So we've got, and I just want to give some credit right off the bat for our design inspiration. Is heavily based on the sort of ball intake and powered floor is heavily based on 254 Cheesy Poof's 2006 robot. And our funneling mechanism is very heavily based on Symbotic 1114's 2009 robot. And we spent a lot of time sort of looking at old robots and how they solve these challenges and put it together. And this is, I don't have a video of our prototype handy, but this is the prototype that was hidden a few weeks ago at the end of our video.
Cool.
And so essentially have two powered wheels here counter-rotating that take a 2-ball wide stream and funnel it to a ball and a half wide and then to 1 ball wide. And it uses the powered wheels to kick them over to make sure that they don't jam. And that's the part that's cribbed from Symbotics. And it works pretty well. At least the prototype did. We haven't had a chance to run the competition or the actual design yet, but it's kind of worked almost as well as the original versions, which has been awesome.
Very cool. That's awesome. That's great to hear. I like the fact that you're using other previous designs as inspiration for your new one. But a very serious question, actually. That sprocket right there in the middle. How do you get that sprocket to stay between the chains like that?
It's called it's magic, really.
Oh, okay.
It's called a floating tensioner. You can see these on a few other robots, and it doesn't require anything special. You got the chain on the top moving one direction, the chain on the bottom moving the other direction, and somehow it just stays in place.
Well, I still don't get it, but either way, whatever, it works. No. That's a bit of a joke between Evan and I, but cool. So do you have any other pictures you want to show us before we move on to talking about the software and the controls part of the robot?
Yeah, I've got one more that I think is pretty neat. Let's pull this guy up here. Stop sharing, share screens. So this is the roller system that we use to power the balls kind of through the funnel. And the really cool thing about this is it's like 90% commercial off-the-shelf parts.
Oh, wow.
Most of this is West Coast product stuff, but we've got Vex Pro HTD pulleys that run between the rollers, West Coast products roller system end caps and roller tube, and then West Coast products 775 Pro GT2 3mm pinion going to a hex bore, half-inch hex bore 60-tooth pinion, and then belts are just either from West Coast products or for odd sizes from STPSI. So the only part that's actually custom or precision machined on this whole thing is this plate here that was made by our sponsor Aerotech.
Nice.
And so it's pretty neat to be able to put together a system like this with just parts that you can buy that don't require much precision machining. And I would hazard to say that you could probably recreate this entire system with all COTS parts with like a versaplanetary and some chain instead of the pinion and belt.
Yeah,
and,
but I mean, it's good to if you have the capabilities to utilize them and sort of make the solution more custom fit to your design.
Well, and you'll actually notice that we have two holes right here. We can swap a versaplanetary into this if we need to.
Oh, yeah.
We were hedging our bets that in case the reduction wasn't big enough, and we needed more torque on this system, that we could just do that without having to make modifications.
Cool. That's a very smart idea. Awesome. Well, guys, thank you for showing us all of your mechanical parts there. That's wicked cool. I look forward to seeing the final robot assembled. I know that you're almost there. But let's talk a little bit about the controls portion of things. So where are you guys standing? Where do you guys stand with that? How's all the programming going? Have you started to wire your main chassis? We saw some speed controllers going in on the video. So let's talk about that.
So I'll quickly put my chip in on the electronics. So for the electronics, we got our electronics panel done. So we ended up having 13 motors, but we just realized that we're using the Spartan board, and it only has 10 PMW ports. So
can you explain what the Spartan board is?
So the Spartan board is a board created by 971 and is distributed through West Coast Products, I believe. But it simplifies the Robo Rio into very easily used ports, and then also adds a gyro in. Evan, do you have any other things to put in on that?
Yeah, I mean, one of the nicest things about it is that it adds latching connectors. It uses latching Molex connectors instead of the regular PWM headers, so that keeps everything from coming out of the Robo Rio. Holds the cables in, and it's got the gyro on it, which we were hoping to use this year, but it's going to be on its side, so we have to use another gyro. And it also provides regulated 12-volt power to sensors that get plugged into it, especially encoders. So if you're using Talon SRXs, those will do the same thing if you plug your encoder directly into the Talons. We use mostly Victor SPs, so if we're using encoders, we like to be able to have the regulated power from the Spartan board.
Cool. All right. So let's talk about the software then. Maura, I know that you're one of the lead programmers, so tell us how the status of all this is.
Well, the software is actually going pretty good. We have all our manual code pretty much completed without all of the PID. And before we knew about what the electronics were doing, we created a new class, a multi-speed controller class that lets us use 6 speed controllers at once. But then we found out Saturday, we can't use that.
Oh, why not?
So, well, It's not
Landon.
the, yeah,
So-
yeah.
Blame Landon.
I was going to mention this quickly, but so
Blame
when we
Landon. Really
realized
quickly
that
talk
we
about
had
it, guys.
BMW ports, we ended up having to use a Y connector. And we're using two Y connectors on two of our drivetrain motors,
Oh,
which
I see.
now makes it to where that special code that they made no longer works.
I see. So you found a hardware solution to a software problem.
Yeah.
Well, we found a hardware solution to a hardware problem that negated a software problem that they'd created a solution for already.
Okay. So,
But it's good practice. Good practice.
cool.
Builds
So,
character.
so beyond that, Maura, what else is going on with the software?
We have been updating our vision tracking, and we found out that the camera that we bought, it was an Axis camera, caused grip to crash.
Ooh.
And we used a USB webcam, tried that out, and it actually worked way better. So we're going to be using something around the lines of a webcam than a regular camera.
Very nice. So have you managed to start implementing some of the vision stuff on like an actual drive base, getting it to line up and find distance, or are you still trying to grab images through grip? Excuse me.
Still trying to get grip set up with our kangaroo, and we haven't really connected it to a robot to like practice test firing or anything. We've just
Okay.
connected it just to use the RoboRio.
I see. Okay, cool. And just so the people at home understand, what is a kangaroo beside an animal from Australia?
A miniature PC. Think of
Okay,
it
guys.
as just a regular desktop computer you carry around, but it's the size of a slim brick.
Oh, okay, cool.
Yep.
So it's not you're not
It's
actually
kind
plugging
of-
anything into a real kangaroo,
No.
like an animal. Okay, good. All right. It's good
I
to
don't
hear.
think those are less than $400.
Oh, that's true. Well, you never know. We have to ask our friends in Australia. Cool. So, last thing we want to touch on is setbacks. What kind of setbacks have you guys seen? Obviously, there's a snow day today, which is way out there for Seattle.
And
what else
yesterday.
happened? And yesterday as well.
Yeah.
Ooh,
It
that's
froze.
Ooh. So, what does that mean for your team now?
So one setback that definitely put us a little bit behind was finals week, which was week 2 or 3. And the thing that hit us hard is just we had a lot of students studying and going home after school. So we didn't have the whole entire team at each meeting.
Oh,
So
yeah.
we were making some progress, but not huge leaps and bounds. And then also some things in the CAD, as everyone knows, is not just like it's going to go together in real life. So
yeah.
just in building some of our mechanisms, we've hit a few minor hiccups. So that and the snow day, but
Yeah.
a few extra days and then maybe lengthening a meeting or two, and we should be right back on track.
Very cool. Good
And
to hear.
Yeah.
also, can I add that sickness, a plague, kind of took over our school
Yes.
and
I
caused
heard about
everyone.
that last week. There was a mass illness from a lot of
Yeah.
folks, a lot of sick folks before
Yeah.
finals. Ugh,
Yeah,
that's-
so we're about a week behind our ideal schedule, I think. We're not actually that really any farther behind than we were last year. So we know there's a clear path to having 2 robots up and running by bag day, but we're just we're trying to get something together for the software team so they can have a real robot to run stuff on and actually bring it online. You were asking about testing the vision code on a drive base. Well, we stole all the electronics off of our Party Parrot drive base to put the practice robot together. We
I
only have
see.
2 sets of electronics, so they have to wait until we finish this robot before they can do anything.
Oops.
Yeah.
Well, that's all right though. You're building a practice robot anyway, so they'll have the whole season to play with it if they want to. Cool. All right. Well, we got a question in from the viewers at home. They want to ask. So again, for the future, if you want to ask questions, just do it in our Twitch chat. This question is from 9Jerry. He asked, "Could you show us some high-speed video of your funnel next week?" I got to agree with Jerry. That sounds like wicked cool. I hope you guys have it running. I'd love to see some video of it working.
Me
What do you
too.
guys think?
Yeah. I think if it's running, we'll have some video of it. I'd love to, have some side by side of our prototype and the real one.
Yeah.
Hopefully working better than the prototype. But we got to finish a robot first.
Cool. Well, that's it for tonight, guys. I want to thank you for joining us here on Check-In once again, like you've done the last 4 weeks. For everybody watching live, if you like the show, you want to see more, make sure to follow us on Twitch and follow us on subscribe to us on YouTube. And if you want to learn when all the interesting things that RSN is doing are happening, follow us on Twitter or on Facebook. You can search for Robo Sports Network or Robo Sports Net on Twitter, and we're right there. But for everybody here on RSN, I want to thank 5803 for joining us once again. And we hope to see you guys next week, and we hope to see everybody back at home next week as well. So until then, have a great week and good build season, everybody.